So can someone tell us what the objective today is? What are you gonna be able to do?
Model exponential growth and decay.
We're gonna do exponential growth and decay. Okay? What is a growth and what is a decay model? Something that grows exponentially is something that, can someone give me an example of something that grows exponentially?
A tree.
Huh?
A tree.
A tree?
Like it grows.
That doesn't grow exponentially.
How
How about if I say,
We're
I'm
talking
gonna
about,
give
like,
you a
math,
penny, I'm gonna pay you a penny a day and double it
Each day.
every day.
That would grow.
That is exponential growth, okay? That's an example of exponential growth. I want you to graph this one right here. Y is equal to 2 to the x power. So, first of all, the first thing I want you to do is look at this equation. Y is equal to 2 to the x power. Can you describe, we have two variables, we have x and y. Where are they? Where do you notice the x is?
I'm looking on the right side.
What is it called?
It's in the exponent.
The x is your exponent. Do you remember what that 2 is called?
Variable? No.
I heard it, base, good job. So 2 is the base, and x is the exponent, and y is your output right here. So I want to generate a table of values. Let's do this by hand. Let's plug in -1, 0, 1, 2, and 3. See how well you remember this math. If I plug a -1 in here, what is 2 to the -1 power? Do you guys remember? You flip it, make it 1/2.
What? What do you
Remember negative exponents, you bring it down?
Oh, yeah.
That's old stuff. What about 0? If I put a 0 here, what's 2 to the 0 power?
Just zero.
It's not 0.
Or two.
It's
Just
one.
two.
No, it's 1.
Oh, I'm tricky.
This is all old stuff. We did this the very first week of school today, or this year.
Today. Alright.
How about 2 to the first power?
Just
Two.
two.
Yeah.
Don't get up to the zeros
What about 2 to the second power?
4.
And 2 to the third power?
Okay.
Good job, Roll.
Okay?
Things okay.
So how are you going from here to here? You're multiplying these each by 2. And that's an example of what exponential growth is. You're multiplying each of these by 2. It's growing exponentially. So let's graph this. What does it look like? Over 1 up 1/2. Over 0 up 1. Over 1 up 2. Over 2 up 4. Over 3 up 8. Now, is this a straight line?
I'm confused on how you graph.
How did I plot the points?
Yeah. How you do that?
How did I plot -1/2?
Oh, that's what you.
Over
never
1 up
mind.
1/2. Over 0 up 1. Over 1 up 2.
When you were saying over, that was going. That's all that was.
Yeah, left, right. The x value tells you to go left, right, or actually left. You're on the y-axis here. Right, right, and right. Now, is this a straight line?
No.
No. That's the difference between linear and exponential. But it's a curve. It's a curve. Now, I know it doesn't stop here because I know that there's numbers to the left, like -2, -3, -4, -5, negative infinity. What's going to happen is this graph is going to get closer and closer to the x-axis. It's going to get really close to that x-axis, but it's never going to be a negative number. Okay, and now what I want you to do is take your calculator and I want you to graph this on your calculator.
There we go. Wait, Lois, do you need one?
Yes, please.
Hey, Josh.
Okay, so y equals 2 to the x power. This is gonna be an interesting video, isn't it, Travis? It's gonna be, you guys watch yourself on YouTube.
Oh, is that YouTube?
Well, yeah.
You're gonna walk by.
Okay, so what I did was type this in the calculator, and I'm gonna hit enter. And what I should get is the same graph that I have. And now I wanna explore this table. I wanna see what's happening. Hit Control T. Are these numbers what we have? I have 0, 1. I have 1, 2. I have 2, 4, 3, 8. What's happening?
It's going up.
It's going up really fast.
Time to, yeah.
Each one of these is times 2. Well, let's go the other direction. Let's see what kind of numbers we're getting here. So when x is -1, it's a 0.5. If it's -2, it's 0.25. I don't know why it pops there and then it freezes on me.
Hit okay. I think you hit okay. Or enter or something.
I did.
Hit escape.
Alright.
There we go. Come on. I don't know why it does that, but. So -5. Notice these y values. Do you see any of them negative? What are they doing? They're getting smaller and smaller and smaller and smaller. And I guarantee you can keep going. That just means 0.000000000. It's getting closer and closer to 0, but it's never going to cross it. Now, all of these problems are in this section are exponential growth or exponential decay. If you look at this, as you're moving along the x-axis, what's happening to your y values? It's getting bigger and bigger. So as x increases, so does y. This is an example of exponential growth. Now, if I were to take these two and stretch it, what does it remind, if I were to straighten it out, make it look linear, what does it resemble to you? A positive line. So, even though it's a curve, this is how I remember it, it's an exponential growth. Because as the x is going up, so is the y. They're both growing. Now, see this model right here? I'm going to talk about this a times b to the x power. When I refer to the a value is the number in front of the base. It's the number that does not have an exponent with it. If you do not see a number in front, like this one didn't, it said just 2 to the x power, there's an understood 1. This is called your a value. Your a value is also referred to as your initial amount or your y-intercept. So check this out. 0, 1 is your y-intercept because the a value is 1. Now this b value, it's nice how we call it b for base. If this b value is greater than 1, it's going to be an exponential growth problem. Okay, now I want you to look at these three. I want to graph these three with you. You can use your calculator. Type in y equals 4 to the x power. Okay, so can you give me some points? hit Control T. I have 0, 1, 1, 4, 2, 16, it's off the page, so 0, 1, 1, 4. And what about if I go the other way? Negative 1.25, negative 2.0625, and it's getting closer and closer to the x-axis. So this is this one right here. So again, this is an example of exponential growth. And what's your a value? What's the a value of this one? 0, 1, I heard it. 0, 1 is your y-intercept. So it's 1 times 4 to the x power. All right, now I want, yeah,
I'm just confused on how you get 1.4.
it's not 1.4, it's 1 times. 1 times 4 to the x power. I want you to see what the a value is. See this model right here? It's a times b to the x power. The a value is a 1. The b value is a 4. I want you to recognize what's a and what's b.
So,
A is your y-intercept. It's that dot right there, 0, 1.
Okay.
Okay, try the next one. Type in y equals 1/3 to the x power. Now, I like to use my little fraction button. So 1/3,
you need the parentheses?
nah, not for this. Now, this looks a little different. What's happening here? Let's plot some points, 0, 1. Now, it looks like as we're going positive, our graph is coming,
Negative.
not negative, it's getting closer to 0. So what's happening with negative 1? Negative 1, 3. So the further to the left you're going, it's getting bigger. So over 1 up 3. Over 2 up 9. This is going, so from the left, it's getting bigger, to the right, it's getting smaller. By the way, what's the a value?
Is it 0 2?
What is it?
Is it 0
What's the a value?
1.
1, it's still a 1. There's a 1 there. So the y-intercept for initial amount is 1, 0, 1. Are you with me? It'll make sense. Let me look at this one right here, hopefully. If you had to predict where it's gonna hit the the y-axis, where would you think it's gonna be? 2. Let's see. Let's graph it.
I'm guessing that's the a value.
What?
I'm guessing that's the a value.
That is the a value, you're absolutely right. So it's 2, and then you're gonna wanna put either times or parentheses. So be careful with that. And guess what, were we right?
Yep.
So you could play around and type anything you want in here. And I promise you, this number right here is the number that is going to hit the y-axis. So your y-intercept is 0, 2. And give me some more points. So hit Control T. So we have 0, 2, we have 1, 6. We have 354, that's huge. So we want to go left. We have 0, 2, 1. Now what's happening? It's getting closer and closer to the x-axis. You're not going to be able to plot a whole lot of points because that's the whole thing, is growing exponentially. okay? So if I were to make a table of values on this one, I have 0, 2. Did it stop?
No.
Okay, 0, 2. Then we have 1, 6. Can you give me the next point? 2, what? 2, 18. And what's the next one? 3 what? 54. Can you tell me the pattern here? These are all going up by 1, but what are these doing?
3.
These are being multiplied by 3. So that's how you know if it's an exponential problem. Where does the 3 show up in this equation? That's your base. Where is the 0, 2? That's your y-intercept. So if you could start off with just one ordered pair, your y-intercept, all you'd have to do is take this base and multiply it by that y value. These are all going up by 1, and these are being multiplied by 3. Now, 2 of these are exponential growth, and 1 is exponential decay. Can you tell me which ones are growth? Which ones look like they're growing? So as you're moving along the x-axis, it's getting bigger. Your y value is getting bigger. The first and the third are both growth models. Now, do they look, if you were to stretch this and make it straight, they should resemble straight like a positive line. So these 2 are growth, and this one is decay. Because as you're moving along the x-axis, as you're getting larger positively, your y value is getting smaller. So this one, if you were to stretch this out, it looks like a negative slope line. Okay, now flip this over. This is what we just talked about, exponential growth and exponential decay. Exponential growth, it looks like a positive line. It'd be positively, if you stretch this out, it'd resemble a positive line. And this one, if you stretched it out, it'd be a negative line. Now, what I want you to do is understand this. I'm going to give you a little trick to remember this. Okay, that's your exponential model. And I want you to look at a number line. 0, 1, and then anything bigger. If the base is between 0 and 1, if the base is between 0 and 1, it's a decay problem. Give me some examples of between 0 and 1.
0.5.
0.5.
Do we gotta write that down, that long?
It's up to you if you want to write it down. If the base is between 0 and 1, oh, I have to sneeze, sorry. It's a decay problem. If it's greater than 1, it's a growth. Sorry, guys. So between 0 and 1, it's a decay. And bigger than 1, it's growth. What's the A value again? Your y-intercept. It'd be 0A. That's where it's going to begin. Decay if it's between 0 and 1. Think of all the numbers that you can think of between 0 and 1. 0.1, 0.2, 0.3, 0.4, 0.45. So think of, if you think of money, anything less than $1. And anything bigger than $1 would be growth. You gotta know this. All right, look at these examples right here. All right, so these are where they get ugly, but you guys can handle it. If I give you this function, y equals 12 times 0.95 to the x power, can you tell me what the A value is, what the B value is? Tell me if it's growth or decay. It's decay. Why is it decay?
Because it's 0.15.
Between 0 and 1.
Yep. This B value is between, so it's like 95 cents.
Oh, can I ask you
Oh,
a
I
question?
thought
I thought you meant the A
I thought
value.
the A had to be bigger than.
Nope, the B value, the base.
Oh,
The number that has the X value,
yeah, then it's.
the boss. I call this the boss. This is the boss.
Big Daddy score.
Big Daddy. Okay,
Wow.
if the B value is between 0 and 1, it is decay. So B has to be less than 1 and greater than 0, it's decay. This one is a decay problem. And where is the initial amount? It's at 12. So your y-intercept, so I could tell you right now, I could give you a general idea of what this graph looks like. It's gonna hit, this is 12, right here, 0, 12, and this thing is gonna be a decay problem. It's coming down like this. Okay? How about B? What's B?
Growth.
Is that growth or decay?
Growth.
It's growth, because it's bigger than 1. So this one is a growth problem. And what's the y-intercept? 0.25. So if I had to draw a graph of this, here's the number 1. It's going to hit at 0.25, and this thing is growing. The y values are all being multiplied by 2. In other words, doubling. 2 is an example of doubling. 3 is an example of tripling. Are we good so far? Okay. So today we're just playing around with the y-intercept, telling if it's growth or decay and kind of the general shape of it.
Close down the voting.
What?
Close it down.
Okay, C. If I give you $1,000 to put in a college savings account for a certain number of years, and you're earning interest, what do you think is going to happen to your money? Is it going to go up or down in value?
So you're earning interest?
You're earning interest. The
Is that
bank is
going-
paying you.
It's going up, right?
It's going to go up. So this would be an example of exponential
Growth.
growth. So what is your initial amount?
1,000.
It's 1,000. And this thing is going to be growing by 5%, so this would be a growth problem.
Yes.
Your money is going to grow very rapidly,
Give me that.
okay? Now, where is your y-intercept? It's 0, 1,000. So we're getting into the habit of these are going to be real-world problems where you do exponential growth or decay. All right, let's see if you can handle got it number 2. For A, can you tell me, is this growth, decay? What information
Growth.
can you give me?
Growth.
bigger
It's
than
growth. What else can you tell me?
Y-intercept is 3.
0, 3. So what's this thing gonna look like? It's gonna hit there, and it's gonna be going down like that. We'll get into the details of the, the table and stuff later. How about B? Is that growth or decay?
Decay.
It's decay,
Oh, even that.
and what's your y-intercept?
0, 11.
So, this thing would hit at 0, 11, and it'd be coming down like that. Okay? And the last one, if I give you $2,000 to put in a college savings account for 4 years, and the account is earning 6% interest, is this growth or decay? It's
Growth.
growth. What's your y-intercept?
2,000.
2,000. And this thing's gonna be going like that. Okay?
Mm-hmm.
All right, now, these problems that looked ugly are gonna be easy for you now.
Yeah.
All I need you to tell me, is it growth or decay? And what's the y-intercept? Problem number 1, tell me.
DK 14.
It's decay, why?
Because B is between 0 and 1.
Good, and what's the y-intercept?
0, 14.
0,
Very good, 0, 14. And I'll give you $1 million, plug that into your calculator. You're gonna see it hit at 0, 14, and you're gonna see it shaped like this. Okay, how about number 2?
Growth.
Why is it growth?
Bigger than 1.
$1.03, it's growth, it's bigger than $1. And what's the y-intercept?
0, 1.
Okay, 0, 1/2, a lot of people like the decimal, 0.5. Number 3, what's that one? Growth, exponential growth, and where is it gonna hit the y-axis?
0, 2000.
0, 2000.
Just when you gotta graph it.
Good luck graphing that one. Now this one, can you type that in your calculator? This is a different one. It says y equals 45 to the negative x power. Now this goes back to something you should have learned last year. And you probably don't remember it. Do you guys remember transformations? No? That's what I thought. So I typed that in my calculator. Does anyone think they know what the y-intercept is?
It's 1.
Okay, let's see if we're right. Do you think this is gonna be growth or decay?
Growth.
You think it's gonna be growth because of the 45?
DK.
But what it is, it's a decay problem. You were correct about the y-intercept,
Because it has a negative.
because that negative reflects it over the y-axis.
Yeah. I knew that.
And that's something we talked about last year. So this is a goofy one. This one is decay,
0, 1.
and your y-intercept is 0, 1. All right, let's see, because it's Wednesday, let's do our homework real fast. Number 18, same thing. I want to hear you guys. Is it growth or decay, and what's the y-intercept?
Growth.
0, 1,
Growth?
29.
And what's your y-intercept? 19.
DK.
Decay,
0, 2.
0, 2.
Growth.
Next one,
Growth.
growth, because 17/10 is 1.7. 0, 12. Good job. Next
DK.
one, decay. Where's it gonna hit the y-axis? 0.8. Next one, what's that?
Growth.
DK.
Decay.
5, 6 is bottom heavy, so this is decay. That's less than 1. 0, 4. Number 23, growth. What's the y-intercept?
0, 0.
Now, where is 0.45? Where do you think that one would hit the y-axis?
Below 1/2.
It'd be like this. You'll see it do something like that. This is about 0.45.
Yeah.
Okay, how about the next one, 24? Growth or decay?
Growth.
Growth, that's bigger than 1. And what's the y-intercept? 0 what? 1 over 100. That's a really small, that's real close, barely above the x-axis. And what do you think this one's gonna be?
DK.
That's a decay one,
0, 1.
and your y-intercept is 0, 1. Now, just can I see real quick? Do you guys understand this?
Yeah.
So three things you should be able to do. You should be able to look at the equation and be able to describe that it's an exponential model. Tell me if it's decay or growth, and the y-intercept.